Question number 10. Explain the concept of destructuring declaration in code. So destructuring declaration to extract multiple values from an object or a data structure and assign them to individual values. So like extracting multiple values and then assigning to individual values. That is destructuring declaration. So we are destructuring a declaration and then assigning to another value. It simplifies the process of extracting and using specific elements from complex. These structuring declarations are typically used with data classes, arrays, and other data structures that provide components. So here in this example, we see that data class is point, x and y are the properties. So pointer has assigned 3 and 4. Then we are passing point value to val x and y. So we have a variable called x comma y. We are assigning point to x and y and then printing x and y. So we will see one example here. Yeah. So if we run this program, we have passed point 3 4, x will be 3 and y will be 4. Okay. Then val x comma y equal to point. Okay. Point dot x is uh, point dot x is 3 and point dot y is 4. Okay. If you print x will be 3 and y will be 4. This is destructuring elements. Okay. So we will get one another point, point 4 comma 5. Okay. And assign val 5 comma z. So this is actually val. So we cannot change it. We need to use a comma b. It is actually immutable. Okay. Equal dollar a comma b dollar. Yeah, a is 4 and b is 5. We have assigned ab to equal to ab. Okay. So this is destructuring component. Destructuring declaration in Kotlin. Okay. This is destructuring declaration. It can be used with data classes. We have done with one example with data classes. We can do with arrays also and other data structure as well. Question number 11. Explain latent initialization. Latent initialization name it is specified that if we want to do a later initialization of the property, then we can use the latent. The latent is used for non-null mutable. Non-null mutable means it where we can use. Okay, it allows you to declare a property without initializing it immediately. If you don't want to initialize any property or any variable immediately, then we can use later. However, you must assign a value to it before accessing it. You want to just like you want to print the value. We have declared later where well name and then string. Then we are printing it. So we need to initialize it. Either it will give null pointer access. Okay. A late init property that typically used when the initialization cannot be done in the constructor or when you want to delay the initialization until later in the code. So if you don't want to initialize it in the constructor, we want to initialize it in any method, then we use the late init with a variable property. So here in the example, you see example method, example class is there. So late init where name. Okay. So where it is a mutable object. So we need to use the mutable object to the later init because we are doing the later initialize and in the where we can change the value well we can in the where we cannot change the value, that's why we use the where with later init. So the name, then we are initializing name variable name property in the initialize method. Okay, then we are printing the we are using the print name method to print the name, print the value of the name property. So here in the example, in the main method, we see one main, then well example equals to example. So we have declared an object of the example class. Then example dot initialize. We are initializing the value. then we are printing the value example dot print name. So we will see an example of this. Yeah. So in this example, see let it where name has been initialized, not initialized, and we are using later it. So if you want to do a later initialization, then the later it. Okay. Then initialize in the initialize method, we are initializing name property, and then we are accessing it in the print name. So if we print this, the output will be John. Okay. Whatever we are passing. Okay. Now if I don't initialize it, okay, and then print, then it will give null pointer access. Yeah, it is not giving null pointer exception because we have checked here condition. Okay. We have used here the operator to check if it is initialized or not. Okay. We can do this as well. If we don't do this, it will give date in property name has not been initialized. It is throwing an exception. Okay. As mentioned in the theory part, we see. Okay. So that's why we have used this operator. For such an operator, it is also an operator for using the null safety, checking the null safety, and example a dot initialize in the example dot initialize the initialize variable, and then in the example dot print name we are printing the name. Okay. So to print for you. Yeah. Question number 12. Explain lazy initialization. So lazy initialization is used for both immutable and mutable property. So for the lazy initialization is used where and well both the property. So it allows you to declare a property. Okay. We can declare a property like lazy well or where name string. Okay. And initializing it lazily when it is accessed for the first time. Okay. So when the property is accessed for the first time, we can initialize it at that time only. Okay. So the initialization code is executed only once, and so the initialization code will be executed once, and the result is cached for the subsequent access. So in the lazy initialization, the result will be cached. Okay, so it will be cached in the memory, and then it can be used for the later part of the program. Lazy initialization often used to defer expensive computation or delay initialization until the value is actually needed. So lazy what will happen, so when we do the first initialization, at that time the value will be caught in the cache memory, and then we can use that value later. So here in this program we see well lazy value, okay, string by lazy. So by keyword you will use to do the lazy initialization. So initializing lazy value. So we have initialized the lazy value. Okay, then println first in the first call, it will what it will do, initializing lazy value by the value lazy value. Okay, then in the second println, it is like it has cached the value, and then that value is printed, cached value is printed. Okay. So in the first initialization, it is initializing the value, and then in the second println, it is using that cached value. So we will see one example. So in this program, we see what is the best part of it is like if we declare initialize any variable as lazy. Okay, we declare any variable as lazy, like lazy initialization we do, then we can use the cached value in the later part. Okay, so here in the output you see initialize. Yeah, first println, we do println. Okay, so using this lazy value we are calling, it is a lambda expression actually. It will print initializing lazy value. Okay, then lazy value it will print value part, it will print, and then in the second lazy value second call, it will print only the value, not this println. So that means, so that is like it has catched that particular value only. Okay, like if I print here that hello, then yeah, it has catched the value of the string part hello, and then in the second part, second print array, it is printing that value only, not printing, not calling the lambda expression and entire println everything.